everyone, Ref here, and today's video I'm going to be explaining Newton's 3 laws of motion. These are such beautiful laws that govern the world around us. You don't even know it, but every single law is applying to you no matter where you are. That's what makes them so amazing. Alright, come on, we got some laws of physics to explain. You thought. Nope. I'm not that good on a skateboard. Let's go. Now, how many outside forces are acting upon this thing right here? Well, you'd be surprised to hear the answer is actually a lot. So, first, we have the wind, but it's not very strong. We also have gravity, which keeps it from falling. But you can mostly predict how something's going to act. Newton's first law of motion is objects in rest stay at rest, and objects in motion stay in motion unless acted upon by an outside force. So you'll see, this thing right here is in rest. You know, it's not moving. There are no outside forces acting upon it. But then, if I went kick, bam, it would just fly into that wall, you know? And then it would be in motion, and it would stay in motion unless acted upon by an outside force. So, really quick, let's try to guess what would happen if I were to kick it into that wall. So first, I kick it, and immediately there's a little bit of resistance to the kick because it wants to stay in motion, or it wants to stay at rest. But then it's going to start flying this way, and there's obviously friction, so it's going to lose speed as it goes over these bumps and other objects with friction. You get how friction works. And then it's going to go bam. And when it goes bam, because it wants to stay in motion, it's just going to, you get the idea. So actually every single one of Newton's laws are applying to the skateboard right now. I'm just explaining it using the first. Here we go. So, yep, like I said, it loses speed. Bam. So we just accurately predicted what was going to happen to the board using physics. So, Newton's second law of physics is force equals mass times acceleration. What that means is how the amount of force that is in an object, and a force is a push or a pull, is equal to the mass times acceleration. So mass is just how much space an object takes up. How much space an object takes up multiplied by how fast it's moving is how owie you're gonna be. So we can actually test this out by just, you know, owieing me. So if I were to do this, you could see, bam. Not bad, you know, didn't hurt too much. Now, here's the fun part. We can also predict the amount of newtons of force that's going to be acted on the board using the second law of motion. So, if we were to put this right here, and remember, the first law is still acting. It still wants to stay still. So, the second law of motion, force equals mass times acceleration. So, let's just pretend right now that we're creating a new unit of measurement. And this board right here is 1, okay? And if it were to run down this, in our new units of measurement, it would have an acceleration of 1. Obviously, it's going to lose a little bit of friction over here, but you can actually predict how hurtful it's going to be because 1 times 1 equals 1. So, let's call this a reton because, you know, they definitely don't use skateboards when they're calculating newtons. So, I'm not actually going to hit myself with this because it will hurt a lot, but you can see it actually went by faster. Force equals mass times acceleration. So the bigger an object is, and the more hurtful it is, the better. Now, there is one thing though. when I hit this, I can tell you right now that this is not accelerating, you know, but it takes up mass. So how come? Ow, that hurt. Why? Newton's third law of motion. And really quick, there's actually a secret fourth law of motion that I'm going to say before the third. And that is that law of motion is that if you don't subscribe and like, then you're going to get hit by 15 reptons of force, thus exerting 15 reptons of force on the object hitting you, which is your favorite toy. So, we already know Newton's first and second law of motion, but what about his third? If you ask me, his third law is honestly my favorite law. It's literally how rocket ships work. Who would have guessed that a rocket ship was so dependent on just a law? Yeah, Isaac did. So, the final law of motion is every action has an equal and opposite reaction. So, I will now display this. You ready? You remember our new unit of measurement, right? Yeah. Well, this right here was equal to 1 rep of acceleration. So this right here can be equivalent to half a rep, although the numbers don't really add up. So, obviously, mass of 1, half a rep, we know that's going to be equal to half a repton. Now, obviously, we accelerate it, it hits, and it goes backwards. But why does it go backwards? Why not just stop? Why not just phase through it? You know, you get the idea. Well, first, we need to understand that a force is an action. So, you can hear, bam, 1 repton just hit this wall. So, the force is the action is 1 repton of, our unit of measurement is a repton, 1 repton towards the wall. Now, because every action has an equal and an opposite reaction, the wall hits the board with 1 repton. So, let's say this distance right here, from the board to there, is a repton. All right, remember there is friction, so it's not going to be exactly perfect, but we can guesstimate that it's going to be somewhere around this line once we hit it back. And, oh, would you look at that? Physics. Faster it's going, the more heavy hitting it's going to be, so the more newtons. So, that example I just showed you, if we were to do the same distance, but make it faster, oh my god, guys, watch this. Well, would you look at that? Physics. Now, the final thing. We kick forth on our new adventure. Whee! And look. Now, please remember that gravity is also an outside force acting on everything. So that's another variable to be concerned about. But you'll see that this thing is slowing down, even though it doesn't want to, because of wind resistance and friction. I've been saying friction this entire time because down we go, up we go, down we go, up we go. Now you can tell that's been gaining and losing friction, and now just every law of motion. Beautiful. Alright everyone, that was my video. Please be sure to like and subscribe because, oh my god, that took me multiple hours to do. But honestly, I'm really happy that I got to explain Newton's 3 laws of physics to you using skateboards. Comment down below if there's anything else you'd like to see. Bye.